All right, so we've gotten really, really good at multiplying fraction by a fraction or fraction by a whole number. And we remember that multiplying a fraction by a whole number is the same as that number over 1. So we looked at these ones together and we decided, let me pull up my pen really quick for you, that anytime you see a whole number, it's just over 1, because it would mean 5 wholes. And then we decided we multiply by the top, we multiply by the bottom, and then we simplify. We've gotten really, really good at that. And it's gonna mix up just a little bit today. Let me get a little further on. Because we're gonna start doing it with mixed numbers. But you'll notice your area model visuals here are pretty much the same. They're just times you're gonna see it greater than 1. So that's really the only thing that's gonna change here. But we also know, because we're the smartest 5th graders ever, that our mixed numbers, we can turn those into improper fractions. So I hope we're still kind of holding on to that in the back of our head and remembering that. So just know, you guys, even though we're done with improper fractions or we're done with mixed numbers, it doesn't mean that idea goes away. So those ideas are gonna keep coming back. So anytime you see something, you're like, ooh, we've done something similar before, hopefully you're applying what we already learned, okay? So we have, our problem today is a farmer has a rectangular field of 1 2/3 mile long and 3/4 mile wide. So I want you guys to draw in your notebook our farmer's field. It's a rectangle, and this will kind of give you guys a little bit of a better visual here. We know the long side would be 1 2/3 because that is larger than 3/4. So, all right, here is our farmer's field. Again, it looks just like area. It's anything we've always done before. It's just the numbers are a little bit different, right? All right. So if we want to find the area of a rectangle, what do we need to do? Who could tell me? Add, subtract, divide, multiply. What do we need to do? Somebody knows. Thank you. I was gonna say someone knows how to find area. Area is, and look, our friend Melinda knows, multiplication. So our equation for this would be 1 2/3 times 3/4. I want you to write this equation in your notebook. We're gonna look at it for a quick second before we solve it. And I've started kind of using, you guys can use a multiplication sign or you can use the dot. I know we've been kind of working on both, right? Okay. So Melinda has made a drawing of this. Personally, I look at this and I'm like, 1 2/3. I'm kind of thinking to myself, how do I split this into 1 2/3? Right? Because it just seems a little bit different. So now we're going to explore a drawing that shows exactly what this looks like. So hopefully you guys already have this written down, because we're going to go, I have to scroll down just a little bit to show you what this would look like. So here are the steps that it takes to do this. And this is, Melinda's explaining this to the farmer. So 3/4 on the top should be pretty easy to do. So in your notebook, I want you to split your long ways, and I'll do mine over here. You can see it here also. Again, if you have different colored pencils, that's helpful. If not, you could use different patterns maybe. So let's split our top one. Oh gosh, much easier for you guys to do this. Here we go, the line tool. Let's split our top one into 4ths. That shouldn't be too hard. So hopefully in your notebook, you've got it split into fourths. Fourths is something we're really comfortable with. That should be pretty easy. All right, well, we know that it's actually just 3/4. If I colored in all 4/4, it would be too much. So now is when I want you to either take a different color, or maybe one way you do polka dots, one way you do stripes, however, just to show which sections you are using. I'm just going to use red and blue because that's what's shown in the example. If you don't have colored pencils, just use different patterns or something. All right. There's my beautiful drawing. Wow. All right, so there's my 3/4. Now my side length, this is where it gets a little bit different because it's a mixed number. So this is where it becomes a fraction and a whole number. So I want to show you how this works. And once you see this, it's actually going to make total sense. 1 2/3, we know we're working in thirds. So we know whatever we're doing to this rectangle needs to be split into thirds. We can't keep it in fourths because those aren't the same thing. But now this is where, when I looked at this, I was like, 1 2/3, how would I draw that? But then I realized, okay, so I'm going to be splitting this into thirds. I'm just going to have more than 3/3, right? Because I know it's more than a whole. So what you need to do is it's more than 1. So I'm actually going to split it into 2. So I want you to take your pencil and split it into 2. Right down the middle. Let me do it this way. Here. So there's the start of this. Here's 3/3, and here's 3/3. But I need to use 1 2/3. So split your top half into thirds. Draw 2 lines in your top half. 1 and 2. There's 3/3 there. And then on your bottom half, do the same thing. So go ahead and split 1 and 2. And the thing that we have to remember here is that this line down the middle turns it into 2 wholes. Here's 3/3 and here's 3/3. So I'll draw a little drawing, and if you want to do this with me, it might be a little helpful. It might be helpful for you. Is this part right here is 3/3, and this part right here is 3/3. So the difference that changes here is that when we were doing this before, we probably would have looked at this and been like 1 2 3 4 5 6. We're working in sixths. But in this case, we're actually splitting it into 2 different wholes. So now what I need to do, and this is where you're going to take your different color or your different pattern or whatever you're working on, and this is where you're going to split it. I'm going to do mine a little skinnier here. I have 1 2/3. Who can tell me what 1 2/3 is as an improper fraction? If I wanted to turn this into a fraction, what would I do to it?
That would be 5/3.
And how did you do that, Justin?
Because 1 whole is 3/3.
Mm-hmm.
So if you take our 2
Mm-hmm.
as our numerator, plus 3 equals 5.
Exactly. So Justin knows that, okay, 3/3 gives me a whole. So if you want, you could color in the whole top 3/3. I know that all of these top 3/3 are included. Got it. And then I have another 2/3 down here. So this is exactly the same as the area models we were using for multiplying fractions. Just this time you have a whole and another number. Or if you want, it might even be easier to turn into an improper fraction. It's kind of whatever's easier for you. I find the improper fraction to be easier because I'm like 1, 2, 3, 4, 5 lines done. But again, as long as you understand, it can be both. All right, so now what we need to figure out is whenever we're doing this with models, and you will have these models in your lesson today, that you're only looking at whatever is shaded both, whatever is overlapped. So the only thing we're counting is whatever is shaded both red and blue, or in your notebook, maybe it's both circles and dots or stripes or whatever it is you're using. So I would go here and I would say, okay, I know right here to here to here is both. So I want you to kind of draw a line around wherever you see both colors or both stripes or whatever it is that you are using. And then I want you to count how many of these boxes actually have both colors. Can anyone tell me how many actually overlap?
15.
15.
24th.
Thank you. 15.
24th.
But is it 24th? Because we decided this was a whole, the top half was a whole, remember? And the bottom half was a whole. So in this case, it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 15 twelfths, because when we split it down the middle here, this is a whole and that's a whole. And again, this might be a little bit confusing. It's okay because we're going to keep working on it. So one way that would make this a little bit easier is, you guys are going to be really happy to see this. You have to know how to do it as an area model like this. You will see this on your homework. You'll see it on your test. But there is a shortcut with multiplication. So you just have to be able to know how to do both. The trick here, and if you look at this drawing, and you'll see it today, where they split the holes. 1 hole, 2 hole, 1 hole, 2 hole. So just keep in mind that each one of these sections is a hole. And you might even see, I'm not 100% on your homework today, you might even see them with 3 holes sometimes. Maybe it's 2.5. And you have to go over 2. You have to go down here. It's whatever is in this hole is what your denominator is. So an easier way to do this, I hope you guys have this all written down. I'm going to clear this really quick. I'm going to kind of show you the shortcut way. So when we scroll down here, exact same thing, we have, and I would write this down in your notebook, here it is as a multiplication problem. So we did exactly what Justin talked about. We took 1 2/3 times 3/4, and we turned it into 5/3 times 3/4. So you guys, the only difference that we have right now with mixed numbers is that you're just turning them into improper fractions. And then after that, you can multiply them like any other fraction. Now, guess what? Multiply the numerators, multiply the denominators, and here we go. So that doesn't change. The only extra step we have with this is turning this mixed number into an improper fraction. From there, you're multiplying 2 fractions just like you've always done. So that's what we have to keep in mind here, is it's really no different. Once we have 2 fractions here, we multiply the top, multiply the bottom, just like you did last week. So I would make sure you have this in your notebook to kind of remind yourself, okay, if I see a mixed number, I turn it into an improper fraction. I multiply my numerators, 5 times 3 is 15. I multiply my denominators, 3 times 4 is 12, and I'm left with 15 twelfths. And then you want to simplify, and this is the thing we've been working on, right? 15 divided by, and maybe you put this in your notebook too, divided by 3 is 5. 12 divided by 3 is 4. I'm left with 5/4. Preferably, you guys, if you're starting with a mixed number, usually they want you to end with a mixed number. So if instead of leaving it as 5/4, turn it into 1 1/4. So this, again, this goes back to what we've already done. We've done mixed numbers to improper, improper to mixed numbers a bunch of times. So really it's no different. It's just converting between the two. So we're going to do one more together. And I want to work through it with the shortcut too. So you guys will see this, and they're reminding you here that 1 1/2 is 3 halves, 1 2/5 is 7/5. I'm not going to have you draw this in your notebook because this one would take really long to draw. But just as a reminder, 1 1/2, it's split as a whole here. Here's 1, here's 2. They're each split into halves. You guys can see that. So I actually have 4 halves. And then same thing with fifths. You can see the line down the middle here. 5/5 up here, 5/5 down here. So just being able to look at these is really what I want you to be able to do. You're not going to draw these forever because, again, this is, what, 35 sections or something outrageous. You're not going to draw all that. But just knowing that when you're looking at it, what you're looking at. So now, I want us to jump down to number 3. We're going to skip over this area model. You guys will have to see them, but I don't worry too much about that. We know that if we have a mixed number, we have to turn it into an improper fraction. So I want to give you guys a quick second in your notebook. Turn both of these into improper fractions. You're going to have to convert both of them. I'll give you a quick second, and will you just shout out when you're done? Don't shout the answer, but just let me know you're done. You don't have to solve right now. All I need you to do is just convert them into improper fractions. That's it. Okay, thank you.
I got it.
I got
Okay.
it.
Okay, good.
I'm done.
Okay,
Can I share what I had?
sure, I'd love for you to share. Can you tell me how you did it?
So 1 2/5 is 7/5.
And how did you do that?
Well, I added the 5th to the 2, and it was like it was 7, and the 5th and the 5 for the denominator always stays the same, and then you just
Thank
always
you.
take out
Can
the
you
1.
say that one more time, Amelia? What did you say about the denominator?
It stays the same.
Thank you. Okay.
And then for the 1 1/2, it's 3 2 because 1 plus 2 equals 3, and the denominator stays the same, and you just have to take out the 1.
Yeah, so you guys, that was remember our shortcut from a long time ago, changing these into improper fractions was multiply the bottom, add the top. So 5 times 1, or 5/5 is what you end up with, right? So you multiply the bottom, and then you add the top. If you guys need to write this in your notebook to remind yourself, that's a really good idea. So I'm going to write what Amelia said. I'm just going to make it a little bigger over here. So I would probably put this in your notebook, 1 2/5. I multiply the bottom. So 5 times 1 is 5. And then she said you add the top, add 2 more, and you end up with 7. So that equals 7/5. Good. All right, Amelia, can I keep you on here and have you finish it for us?
Mhm.
All right, Amelia, now that I have 2 fractions, what do I need to do?
You need to multiply them.
Yep. So what is 7 times 3?
21. 21.
Thank you. And then 5 times 2 is?
10. 10.
Excellent. Am I done?
No, you can go lower.
And how did I do that? Can I pull some wholes out of there? Can I take a whole number out?
Yes.
What would a whole number be if I'm working in tenths?
That would be a...
So our denominator is tenths, so it takes 10 pieces to make a whole, right?
Yeah.
So I could take 10/10 out of 21. Could I take 2 wholes out of that?
Yeah.
Yeah, because that'd be 20/10, right?
Mm-hmm.
So I could actually take 2 wholes out of it because I know that would be 20. And how much would I be left with?
20.
Well, I took away 20. I'll put it up here. I took away 2 wholes, or 20. I had 21, so I only have 1/10 left.
Oh.
That's it. Does that make sense, guys?
Yeah.
So if I put it up here, let me put it up here and give you some extra room. So 21 over 10. This is what our answer was, right? I could take away 1 whole, which would be 10/10. Again, put it in your notebook. 10/10. And then I'm left with 1 and 11/10. Okay, that looks really weird, right?
Mm-hmm.
Take away another 10/10, because that's another whole. I'm now left with 2 and 1/10. How's that sound? Can I go any smaller? 1/10 is stuck. That's it. So that is actually, and if you guys are seeing this, it's the same thing we've done. The only thing you're doing is changing improper to mixed numbers and mixed numbers improper. Everything else is the same. So really all you're doing is you're taking your starting point. So today you will have a starting point that are mixed numbers. Here, 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 here. And then you just have to turn them into improper fractions. So let's do number 6 together and then I'll let you guys go, okay? So if I wanted to turn 3 2/3 into an improper fraction, what would I need to do? Who could help me out here? Addie, can you help me? Maybe? Anybody? Asher, you could help me. No, you know.
Oh, no. I know.
You do? Okay, thank you, Justin. Help me out here. What do I need to do?
So first of all, what we need to do is we need to convert 3 2/3 into an improper fraction.
Yes, sir. And what do I need to do that?
So 1/3 is 3/3. So 3/3 times 3
Yep.
is 9/3.
Yes, sir.
Plus 2 is 11/3. So we have 11/3. That's our improper fraction.
Thank you, sir. So I'm going to do what you just did, and I'm going to make it big up here so everyone can see what Justin was talking about. So we know that 3 wholes, if we're working in thirds, 3/3 is a whole, 3/3 is a whole, 3/3 is a whole. 3 of those, Justin said here, 3 groups of 3/3 will give us 9/3. 3 times 3 is 9. I add those 2 extra thirds, those 2/3 hanging out, and I end up with 11/3. Then, Justin, now I'm stuck because I have a whole number of 7. What do I do?
Wait, how is it thirds? If you multiply the bottom to the middle number, shouldn't you be getting 9?
It becomes 9/3, yeah. So all we're doing, so Rydian, we're solving for the denominator. Like Amelia said before, the numerator stays the same. If I'm right here in thirds, I'm gonna stay in thirds. But 3 groups of 3/3 would give us 9/3. Add 2 more, we're at 11/3. So basically it's the same as if I was to draw a rectangle. It'd be, there's a group of 3/3. There's a group of 3/3. Here's a group of 3/3. So there's my 3 wholes. And then my last one is only 2/3 because I'm not using all of them. So I'm gonna go like this on my last one. I'm just gonna shade in 2/3. 1, 2. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/3. Does that make a little more sense, Rydian? All right. Now, Justin, what do I do, though, because I have a 7? What do I do with a 7?
So what you do with the 7 is you make that a fraction.
Okay. And
You
what do I
make it
put that
7 holes.
7 holes? Yep, 7 over
You
1.
make-
All right. 11's trick. What's 11 times 7?
11 times 7 is 77.
Easy peasy. And 7
77.
times 3 is... Or, oh, excuse me, 3
three
times
times
1.
one.
What am I talking about? 3 times 1.
3 times 1 is 3.
Oh, my goodness.
3.
So
Okay.
we have 77 thirds as
I was
an
going to say,
improper
what the
fraction.
heck do I do with this?
Yeah, and that's our improper fraction. We can simplify it.
This is a hard one, you guys. Immediately I would look at this and be like, I have no clue what to do. I would probably just go to long division at this point, because to figure out how many times does 3 go into 77, because this is just, you could try mental math, guess and check, but it might take you a while. So this is where you could go, I know 3 goes into 7 2 times. 3 times 2 is 6. I subtract. I'm left with 1. I drop down my 7. 3 goes into 7 2 times. Wait. Is that right? I feel like I'm messing something up here. Hold on.
I got the answer.
I'm running into my own screen here and I'm getting stuck.
Yeah.
You guys, I can't get out of it.
Yeah, I did mental math. I know it.
I was gonna say I could do this better with mental math, actually.
Yeah.
All right. Justin, how'd you do with mental math? Because that would be a better way to do this, actually.
So what I did was I already skipped, because I knew that 3 goes into 60 20 times.
Mm-hmm.
So I skipped to there to make it easier for me and just kept on going.
That
So
is what I was doing in my head, and I realized what I did.
Yeah.
Can you guys see this?
That's what I got.
Okay, the addition subtraction sign's in my way, but let me drop down my 7. And then you say 3 goes into 17 5 times. Minus 15, I'm left with 2. So it's 25 2/3. Again, you guys, if this is hard to go this far, do your best, okay? If you're like, Miss Anderson, this simplifying business is getting too hard, do your best. I'm more worried about the fact that you can change mixed numbers into improper and then multiply, okay?
Mm-hmm.
All right, so here's what you've got today. Let me just show you your assignment and then we'll go. Yours is, so many clickers on here, there we go. Actually, I'll just go to the assignment. I believe I deleted some pages for you guys. It's pretty short today. All right, so I'll show you 3.6. Must be on the second page here. And I am gonna go on, you guys, I think today, and delete some of your old assignments, because some of you guys have so many assignments hanging out. You're gonna notice it looks really similar to what we just did. You're gonna have to identify some models and then multiply. Again, if you need examples, click View Example, it will show you. If you need step-by-step, it breaks it down into step-by-step for you. So please use those features, okay? They are very, very helpful. All right, so let's do this. I'm gonna exit out all this, let you guys go for a quick second.